This will be first step.
Hello dear students, this is Ramarao sir. Today I will going to start the concept of the torque in rotational mechanics. Okay, so what is the torque? What is the torque? Tell me. What is the torque? The turning effect of an object is called as a torque. Suppose consider an object. Here this is an object. One end is fixed like this. At the other end I am applying some amount of the force like this. Then what happening is that this direction of the object is changes. That means this object is turning like this. So the turning effect of a force is called as a torque. Is it clear? See here. This is suppose consider what is that a object. A object of one end is fixed here like this. The object of one end is fixed like this. Okay. The object of one end is fixed. At a distance or from the point of hinging, I am applying some amount of force like this. A force of F is applied on the other end. Then what happening is that this rod would be rotated like this with an angular velocity omega. So the turning effect of force from a fixed point is called as a torque. So this is represented by, it is represented by generally torque tau is equal to force into perpendicular distance. Torque tau is equal to force into perpendicular distance is called as a torque. So what are the units of torque? Units are, what are the units? Units are Newton, meters, units, and dimension formula. What is the dimension formula of torque? So the dimension of the force F is equal to MA, that is equal to MA minus 2 into L, that is equal to M L square T power of minus 2 is a dimension formula of torque. Okay. Suppose in the two-dimensional system, when a particle is moving in the two-dimensional system like this, okay, how would we can define the torque about a reference point? See, suppose consider two-dimensional system. This is a two-dimensional system. Okay, okay, it's a two-dimensional system, and a particle would be at a distance of r. The particle would be at a distance of r from the origin like this. Okay, which is at a distance of r from the origin. So this is the direction of motion of the particle. When a force of F newtons is applied like this, when a force of F is applied like this, when a force of F newtons is applied along the direction like this, which is making an angle theta in the direction of motion, then what happening is there? The particle would be, the motion of the particle would be turn off like this. Okay, the particle of the motion will be turn off, where force can be resolved to rectangular components in the direction of angle is F cos theta. Other than direction of motion is F sin theta. This force can be resolved to rectangular component here beta. One is F cos theta and other one is F sin theta. इसका perpendicular distance क्या हो जाता है बोलो? Either the angle of inclination theta already we have taken, this angle and this angle P is equal to set. So what about the distance? What about the distance? The distance. What about this distance? The distance would be is equal to r perpendicular, which is equal to r sin theta, is called as a perpendicular distance. This is why I am taking 4D. Therefore, the torque acting on the object about this point 4 can be written as what is that? Torque W is equal to force. Force means F sin theta. F. Torque W is called force into perpendicular distance. So torque W is called force into perpendicular distance. That is equal to r sin theta into F. Simply, this is what I am writing. Torque W is equal to F r sin theta. This is a torque tau. Torque is a vector quantity. Okay, it has a dimensional form of energy, that is ma square t power of -2. So when torque changes depends upon the angle. If theta change हो जाते तो क्या हो जाता है बेटा, torque would be change हो जाता है. So if theta is equal 0, what about the torque? If theta is equal 0, torque tau would be equal to how much? Sin 0 is equal to 0. That is equal to minimum torque will be acts on the object. Suppose if theta is equal to 90 degrees, if theta is equal to 90 degrees, what happening is that tau max is equal क्या हो जाता है बेटा, r cross f हो जाता है. Tau max क्या हो जाता है बोलो इधर, tau max would be is equal to, what would be the tau max? Tau max is equal to r cross f. This is a maximum torque acts on the particle. Is it clear? Torque means what is the torque? The turning effect of a force is called as a torque. Simply, you should remember the turning effect of force is called as a torque. So, based on the concept of the torque, see one problem. Suppose consider a particle in the two-dimensional plane here. So, two-dimensional plane, मतलब three-dimensional plane पर है. X, Y, Z है. It's a three-dimensional plane है बेटा. X, Y, Z, X, Y, Z है. X, Y, Z axis है. ठीक है. A particle has to be displaced in the three-dimensional plane from 0, 1, 2 meters to 1, 2, 1 meters under the influence of an external force है बेटा. External force ऐसा लगा दिया इसमें. The particle has to be displaced from initial position would be at 0, 1, 2, and it would be displaced final position of 1, 2, 1 meters under the influence of an external force. F bar is equal to I plus 2J plus K newtons. Okay. Then find the torque acting on the object. Torque acting on the object कैसे निकालना पड़ता है बोलो बेटा. Generally, what is the torque? Torque W is equal क्या हो जाता है बोलो. Torque W is equal to R cross F है इधर. Torque W is equal to R cross F है. But here R value direct नहीं दिया बेटा. Where R1 दिए. This is a, let's take X1, Y1, Z1 coordinate system. These coordinates are X2, Y2, Z2 लेवल. ठीक है. इधर R bar क्या हो जाता है बोलो बेटा. R bar is equal to X2 minus X1 of I plus Y2 minus Y1 of J plus Z2 minus Z1 of K हो जाता है. ठीक है. Therefore, R bar would be equal to what is R bar? X2 minus X1. X2 minus X1 means 1 minus 0, that is equal to I, plus Y2 minus Y1. Y2 means 2 minus 1 plus J plus Z2 minus Z1, that is equal to minus K meters. This is the value of R bar. Okay. Now we have to calculate the torque acting on the object. कैसा निकालना पड़ता है torque acting on the object बोलो. Now W is equal to, already you know, R bar cross F bar है. R bar cross F bar है ना torque tau. Torque tau would be equal to R bar cross F bar है बेटा. Okay. That is equal to, this is we have to calculate the date है. I, J, K है. So R का I, J क्या हो जाता है बोलो. Where this is a vector of R है बेटा. This is a vector of R है. Position vector of R है. That is the I value how much? Coefficient of Fi 1, 1, minus 1 है बेटा R का. F value was given 1, 2, 1 है. That is called I of. We have to calculate the date I. This 2R gets cancelled out. This 2R gets cancelled out. 1 into 1, 1 plus 2 हो जाता है. This is a minus 2. Minus J of, what is the value of it? This 2R gets cancelled out. This 2R gets cancelled out. 1 plus 1 of This 2r gets cancelled out. 1 into 1, 1. 1 into minus 1, minus of minus 1 plus k of what is the k? K of these two lines are gets cancelled out. 2 minus 1 हो जाता है बेटा. 2 minus 1. Therefore, the torque acting on the object is given by what is the torque? Tau is equal to Vi minus 2j below plus k. So this much torque would be acts on this particle. Okay. What is the magnitude of the torque? The magnitude of the torque would be given by the magnitude of torque is equal to mod of torque is equal to root over 3 square plus of minus 2 square plus 1 square, that is equal to root over 9 plus 4 plus 1. Okay. That is equal to root 14 Newton meters. So this is a torque acting on the particle. Okay, understood? How can you calculate the torque? Next, और एक problem देखो, the same model है, वो JEE problem है बेटा. This is JEE 2025. Okay, a force of F is equal to I plus J plus K newtons acting on the particle, and which is displaces the particle. The displacement of r bar is equal to I minus J plus K meters. I minus J plus K meters. Then find the magnitude of the torque acting on the particle. वो भी कैसा निकालना पड़ता है बोलो? Force दिए and displacement दिए. इसमें बहुत easy to calculation of the torque है बेटा. What is the value of torque? बोलो torque is equal to r bar cross FRA, that is equal to mod of or det of I comma J comma K. So r value was given 1 minus 1 1, and F value was given 1 comma 1 comma 1. ठीक है, ऐसा दिया. Okay, now we have to calculate the det value data, that is I of this I है, वो दोनों भी कैंसिल हो गए. -1 of -1 हो गया. This is -1 of -1. Okay, minus j of this column, this row will get cancelled out. This column, this row will get cancelled out. 1 minus 1 हो गया बेटा, plus k of क्या बेटा, वो दोनों भी gets cancelled हो गया. कॉलम एंड रो है. 1 into 1 1 है, plus 1 हो जाता है बेटा. Plus of minus plus is, that is the torque acting on the object is given by what is that बोलो? The torque acting on the object is given by minus 2i, वो 0 हो गया ना, वो भी 0 है, 0 plus 2k plus 2k. This much torque will act on the object. Okay, the torque acting on the object is given by this much. That is torque is equal to क्या हो गया बोलो? minus 2i plus 2k Newton meters. ठीक है, ऐसा निकालना पड़ता है टॉर्क. नेक्स्ट देखो, नेक्स्ट प्रॉब्लम देखो जेई का, वो भी जेई है. जेई 2025 है बेटा. नेक्स्ट प्रॉब्लम देखो, इधर जेई 2025 है. जेई 2025 देखो. Suppose consider a solid disk है बेटा. This is a solid disk है. Solid disk. It has a mass m है बेटा. तो solid disk कैसे है? Solid disk कैसे है? This is a solid disk है बेटा. तो solid disk कैसे है? This is a solid disk है बेटा. Okay. It has a mass m is equal to 1 kilogram. Okay. And which is rotating about this axis of rotation ऐसा. और सॉलिड इससे इसका मास दिए m इज इक्वल टू 1 किलोग्राम दिए, m is equal to 1 kilogram, which is rotating about an axis of rotation. Due to how much amount of the torque is acting about this point O, the torque acting on the object was given. Torque tau is equal to 25 pi Newton meter. Due to this torque acting in the time interval of 40 seconds, its rotation frequency has to be changed from F1 is equal to 1800 revolution per minute to 2100 revolution per minute. 2100 revolution per minute. Then find the radius of the disc. Find the diameter of the disc. Find the diameter है. Diameter कितना हो जाता है इधर से इधर तक. Find the diameter of the disc. D is equal to OR is equal to कितने को भी निकालना पड़ता है. Find the diameter of the disc. 2R D is equal to 2R is equal कितने को भी निकालना पड़ता है. ठीक है. Problem देखो. A disc of mass 1 kilogram due to acting the torque of 25 pi newtons per meters in 40 seconds. Due to that, what happening is its frequency has changed from 1800 revolution per minute to 2100 revolution per minute. Then find the diameter of the disc. ठीक है, बहुत आसान प्रॉब्लम है. कैसा करना पड़ता है बोलो. इसमें क्या दिए बेटा, टॉर्क दिए बट एंगुलर फ्रीक्वेंसी है, ओमेगा वैल्यू नहीं दिए. इसमें फ्रीक्वेंसी निकालना पड़ता है. वी शुड हैव टू कैलकुलेट फ्रीक्वेंसी फ्रॉम द गिवन डाटा. ओके, so omega 1 is equal to what is omega 1? Omega 1 is equal to 2 pi f1 है बेटा, that is equal to 1800 into 2 pi by 60 revolution per second. Revolution per second. Okay, that is the 0 gets cancelled out है बेटा. 6 1s are 6 3s are. Okay, ठीक है. That is equal to 60 pi आ गया. ओमेगा रेडियन पर सेकंड में क्या होगा, 60 pi आ गया. These are radian per second. Omega 1. Next, we should have to calculate omega 2 also. How can we calculate omega 2? What is the value of omega 2? Omega 2 is equal to क्या हो जाता है बेटा, इसमें फ्रीक्वेंसी f2 दिए ना 2100 रिवॉल्यूशन पर मिनट. इसको क्या कर रहा हूँ 2100 इंटू बोलो 2 पाई बाई 60 रेडियन पर सेकंड में मिल जाते. तो 0 गेट्स कैंसल आउट है बेटा. 2 1s are 2 3s are 6 है, 3 1s are 3 7s are 21 है. That is equal to 7 pi रेडियन पर सेकंड है. वो भी 65 है ना, that is 60 pi रेडियन पर सेकंड. 60 pi रेडियन पर सेकंड है. वो भी क्या है 70 pi रेडियन पर सेकंड आ गया है. क्या हो गया वो 70 pi रेडियन पर सेकंड में आ गया. ठीक है, इससे क्या निकालना पड़ता है, radius of the the diameter of the disc would be equal to how much, that is we should have to calculate now. But angular acceleration alpha was not given there. With what angular acceleration it will be rotating, that alpha value नहीं दिए, वो भी निकालना पड़ता है इससे. Okay, what is that omega f equation of motion? चलो, omega f is equal to omega a plus alpha into t है, already you know. Okay, what is omega f value? Omega f value is omega 2, that is 70 pi, which is equal to omega a value कितने बेटा 60 pi है. What is the value of omega? 60 pi. That value I have written. plus alpha into p value was given 40 seconds. 40 seconds में it change हो गया. 40 seconds में frequency has to be changed from f1 to f2. इसमें क्या मिल जाता है बोलो? अल्फा मिल जाता है ना. So it will be bring this side 40 into alpha is equal to, it will bring this side, that is called 10 pi. Okay, 10 gets cancelled out. Alpha is equal to pi upon 4 radian per second. Pi upon 4 radian per second square है. Alpha है ना, radian per second square. Radian per second square. Alpha मिल गया है. ओके, और डिस्क है, इसके लिए क्या हो जाती है, इसका मोमेंट ऑफ इनर्शिया. The moment of inertia about the diameter of the disk also already know about the diameter. The moment of inertia about the diameter of the disk was given I is equal to m r square by 4. Because of you should have to apply what is that perpendicular theorem. Iz is equal to ix plus iy है ना, but ix is equal to iy, both will be same. That is 2ix is equal to iz है. ix is equal क्या मिल जाता है, iz अपन 2 है ना, but what is the value of iz? mr square by 2 is whole divided by 2 हो जाता है. That is equal to m r square by 4. Okay, about the central axis, the moment of inertia is about the z axis level. mr square by 2 है ना, mr square by 2 is across the diameter. Across the diameter, the moment of inertia would be is equal to mr square by 4 है. Okay, therefore the torque acting about that point is given by what is that? Torque tau is equal to I alpha हो जाता है ना बेटा. I alpha torque tau is equal to the torque acting about the point where is equal to tau is equal to I alpha. I alpha that is equal to mr square by 4 into alpha को बराबर है. Is it clear? Tau is equal to I alpha is equal to mr square by 4 into alpha. But the torque value was given. What is the value of torque here? See, what is the value of torque here? What is the value of torque was given here? The torque was given 25 pi newtons given. That value substitute in that equation. Therefore, 25 pi is equal to m value how much? 1 kilogram दिए. R square we should have to calculate the R square upon 4 into alpha value we have calculated, that is pi by 4 here better. This is a pi by 4. Pi will get cancelled out on both sides. Okay. Therefore R square is equal क्या मिल जाता है बोलो? R square is equal 25 into 4 into 4. Okay. Or R is equal to root over 25 into 4 square. That is 5 into 4. That is R is equal to 5 into 4 is equal to 20 meters मिल गए. The radius of the disc would be, is the radius है बेटा, the radius of the disc would be 20 meters. What should we have to calculate? The diameter है. Diameter कितने? The diameter of the disc is given by d is equal to 2r है. That is 2 into 20, that is equal to 40 meters. This is the final answer of this question. I hope that you may be understood. Okay, understood or not? Bolo. Note. This is a J 2025 question है बेटा. Question है, find the diameter of the disc. Find the diameter. Find the diameter of the disc. As shown in figure. As shown in figure. This was the question. ठीक है. Next problem, see. Next problem is also, this question was also asked based on the concept of the torque only. Suppose consider a wheel here, beta. This is a wheel. A wheel, this is a wheel. This is a wheel. Has the radius, whatever its radius, it has a radius r is equal to 0.02 meter. Over it, what happening is there? A string has wrapped over it. A string has wrapped over it like this. Okay. When a force of F is equal to 10 newtons is applied across the wheel, what happening is that the wheel is rotating with an angular acceleration alpha is equal to 2 radian per second square. The wheel is rotating with an angular acceleration of 2 radian per second square. About this axis of rotation. Axis of rotation would be like is that around it a string is wrapped like this. At one end of the string is pulling like this by applying a certain amount of the force is 10 newtons. So that's what happening is that the wheel is rotating with an angular acceleration of 2 radian per second square. Then find the moment of inertia of the wheel. देखो problem देखो, वो भी JEE 2025 का क्वेश्चन है बेटा, बट बहुत आसान है. A wheel of radius 0.02 meters. Okay. When a force of 10 newtons is applied. When a force of 10 newtons is applied, as shown in figure, as shown in figure, it is rotating with an angular acceleration. Angular acceleration of 2 radian per second square. Then find the moment of inertia of the wheel. Then find the moment of inertia of the wheel. Moment of inertia कितना हो जाता है बोलो. About this axis of rotation ऐसा है बेटा, ठीक है, which is rotating when we have applied a force of 10 newtons at the tangential point. What happening is it is rotating like this. It's at an angular acceleration alpha is equal to 2 radian per second square. So इससे क्या, इसका moment of inertia कितना हो जाता है? I would be is equal to how much, that is we should have to calculate value of I. कैसा निकाला पड़ता बोलो. So about this point of contact, how much torque would be acting on the wheel? That is first of all we should have to calculate. Okay, the torque acting on the wheel about this point of contact is given by torque is equal to I alpha. But what is the torque? Torque is nothing but the product of force and perpendicular distance. No? What is the force? F. Force and perpendicular distance is equal to I alpha. So from this we have to calculate the value of I. I would be is equal to R cross F upon alpha. Okay. Therefore, I would be is equal to what is the value of I? I is equal to R value was also given 0.02. F value was 10 newtons upon alpha value was given 2 radian per second. This is what I'm writing. See, I is 2 into 10 to the power of minus 2 into 10 upon 2. Okay, is it clear? So 2 will get cancelled out. Therefore, I is equal to how much? 10 to the power of minus 1 kilogram meter square. That is equal to what is the value of I? I is equal to 0.1 kilogram meter square. The wheel has the moment of inertia I is equal to 0.1 kilogram meter square. Is it clear? Is it clear or not? Okay, look. Next problem says, based on the concept of this moment of inertia. Okay, based on the concept of this moment of inertia, the next problem is suppose consider a rod here, beta. This is a rod. This is a rod. This is a rod here. The rod. This is a rod. Rod of length L and mass M. It has a length L. It has a length. It has a length L and a mass M. Okay. Its two ends are fixed here, like this. Its two ends are fixed. Its two ends are fixed from a rigid supports. Its two ends are fixed from a rigid supports. Okay. Both of them, these two ends are fixed with a rigid support only. The strings have the idle. The strings are the idles. Idles means massless and what is the tensionless. Okay. This rod is nothing but a uniform rod only, not non-uniform rod. It is a uniform rod. It has a mass M and length here. So its total mass has to be concentrated at the center, at the center point. The total mass of the rod would be concentrated at the center. This is called as the center of mass. From the center of mass, its total weight will act in downward direction, that is mg. Okay. The question was, when one string has to be cut off, when the one string has to be cut off, what happening is that the rod would be rotating like this. The rod would be rotating. You see, I'm showing here. When the one string of the rod has to, one of the string of the rod is cut off, then what happening is that the rod has to be rotated like this. When the one of the string is cut off like this, when the one of the string is cut off, one of the string has to be cut off, then what happening is there? The rod has to be moved like this. Okay, is it clear? Is it clear? The rod has to be moved downward direction like this. It is rotates like this. The rod has to be rotates like this. The rod has to be rotates like this. Okay. When the one end of the string has to be cut off, what happening? It will rotate like this. It rotates with an angular velocity of omega. With an angular velocity of omega. Then find the tension force in the string. What would be the tension force in the second string? इसमें tension force कितने हो जाते हैं? T is equal to कितने? बहुत आसान problem है, बहुत important है J mains के लिए. This is also J mains problem only. J mains problem. This is okay. Find the tension force in the string. ऐसा निकालना पड़ता है, बोलो बेटा. Initial में क्या है? In the initial position, its weight would be acting downward direction, right? The tensional force, the tensional force will acting upward direction like this. The tension force will is always act away from the touching point. वो string में same है, ऐसा T है, ठीक है, okay. When the string has to be, one of the string has to be cut off, the rod has to be accelerating like this. Okay, with an angular acceleration alpha and linear acceleration a. Okay, so what would be the distance of center of mass about this point of contact? It would be the L by 2 beta. The remaining length also L only. Okay, right. Now, from the free body diagram, it is very clear that the center of mass will act in downward direction mg, and the tension force will be acting upward direction, and it is coming to downward direction with an acceleration a. Is it clear? So, what is the net force acting on the rod in this case? The net force acting on the rod is given by mg minus t is equal to ma. Okay, the net force acting on the rod is given by F is equal to mg minus t, because of it is coming to downward direction now. Mg minus t. F is equal to ma is equal to what is that? Mg minus t है. T is equal क्या हो जाता है? What is the value of t? Mg minus ma. From this t is equal, you can take common m into g minus a. This much tension force will acting, but the rod is accelerating like this. The rod is rotating like this. The rod is rotating about this fixed point. About this fixed point with an angular acceleration here. Its center of mass is also accelerating with an angular acceleration a. Okay, is it clear? So the center of mass which is lies at a distance of L by 2, no? The center of mass will lies at a distance of L by 2. Therefore, about this point of contact, the torque acting on the rod is given by how much torque will acting on this? Torque tau is equal to I alpha. Torque tau is equal to I alpha. But alpha is equal to what is alpha? Alpha is equal to tau upon I. Okay. How much amount of the torque tau is acting about this point? About this point, how much amount of the torque will acting about the rigid, about this fixed point? This fixed point would be at a distance of L by 2. Tau is called force into perpendicular distance. Na? Is it clear? Therefore, the torque acting about this point of center of mass is given by force mg into what is that? L by 2. Perpendicular distance is L by 2 upon I. So what is the moment of inertia of the rod about this one end? The moment of inertia of the rod about the center also already, you know. The moment of inertia about the center of mass is given by ml square upon 12 है. ठीक है. About this one end is given by, about this one end, the moment of inertia would be is equal to ml square by 3. Already knows. Therefore, but we have to calculate the moment of inertia about this one end, because of the rod is rotating like this with respect to this end. Therefore, the alpha value would be is equal to what is alpha? Mg, it's a sign that is equal to mg into L by 2 upon I is equal to ml square upon t. This much angular acceleration it will be rotating. Therefore, Mn will get cancelled out. ठीक है. And alpha value is equal to 3gl upon 2l square है beta. So L also gets cancelled out. 3g upon 2l. With this angular acceleration, it will be rotating. But the linear, with what linear acceleration is coming to downward direction? About the fixed point, it is coming with a linear acceleration or tangential acceleration a. But a value is also already know what is the a. A is equal to r alpha. A is equal to what is the value of r? R means this is the distance of point of contact from the center of mass is called as r. R means what is the value of r? L by 2 into what is the value of alpha? Alpha is equal to 3g by 12. 3g upon 2 L beta. So L will get cancelled out. A is equal to 3g upon 4 meter per second square. So with this linear acceleration, it will be coming to downward direction. Now that value substitute in the equation number 1. Let's say this is equation number 1. This value substitute in the equation number 1. Therefore, equation number 1 implies what is that? T is equal to M into G minus A. G minus A value is 3G upon 4. Therefore, T is equal to M into 4G minus 3G upon 4. That is T is equal to M into G upon 4. So this much tension force will be developing in the string. Therefore, the tension force developed in the string after immediately cutting the one string in the above case is given by what is the how much? E is equal to mg upon 4 newtons. Is it clear? Is it clear or not? See here, this rod was connected like this. Okay. So after cutting the one end of the string, it will be coming to downward direction. But one end has to be, it is fixed only. So that's what it is coming to like this direction. It is coming to like this direction. It is coming to like this direction. Okay. In this case, we should have to calculate what is that. How much tension force is developed over our head. How much amount of the developed force will be developing in the second string, that is we have calculated. That is here. We had applied from the free body diagram. It is very clear that the net force acting on the system is equal to driving force minus opposing force. Okay. So the MA is equal to mg minus TA. So T is equal to m into g minus a. So about this point of contact, the torque acting on the rod is given by I alpha. So from alpha is equal to tau upon I beta. Tau value is the mg into L by 2, force into perpendicular distance, mg into L by 2 upon I. But the moment of inertia about this end is also already known. mL square upon 3. This value substitute here, mL square upon 3. So from this we have calculated the value of alpha. Alpha of 2 is equal to how much beta? 3G upon 2L. So we have got alpha value, angular acceleration. So from this we have to calculate linear acceleration because of the equation has the linear acceleration here. So A is equal to R alpha. But what is the R? R is nothing but the perpendicular distance from the point of contact is L by 2. That is L by 2 into alpha value also already knows what is the 3G by 2L. From this we have calculated value of A. So from this we have calculated what is it? T. The tension force developed in the string would be is equal to T is equal to mg upon 4. Is it clear? Is it clear or not? Next, go to the next problem. Next, move to the problem. One more problem is there. See, this is a J. This is also J problem only. J problem. Okay. Suppose consider a wheel here, beta. This is a wheel. This is a wheel. Wheel I say, which is placed on the step. Step I say na step. Oh, we step here. Wheel I say are. It's a step. The wheel is rolling like this. Okay. This is a wheel. Wheel is rotating like this, which is placed on the step. Which is placed on the step. The step has a height of h meters or a meters at a height of a, and the wheel has a mass m and radius r. This is a step here, the step would be like this is a step which is placed on the step like this. So placed on the step. The radius vector would be acting along the direction. Its radius vector will acting along the direction like this. This is a r. So from this, what happening is there, a force is applying like this. A force of F newtons is applying like this. A force of F newtons is applying from this. A force of F newtons is applying like this. Okay. A force of F newtons is applying like this. A force of F newtons is applying like this. So with what minimum force we had applied on the wheel about the point O, then the wheel is step up. Then the wheel is step up. Then the wheel is step up with what maximum force? With what maximum force or with what minimum force or maximum force we had applied, such that the wheel is a step up. The wheel is step up. The wheel is step up from the step, from this step. Okay, the wheel is step up. Is it clear? A wheel has a mass m and radius r, which is placed on the step. A force of F is applying like this about its center. With what minimum force or with what minimum force we had applied? Minimum or maximum, as you wish. With what minimum force we had applied, such that the wheel is step up. The wheel is step up. That was question. बोलो कैसा निकालना पड़ता है? व्हील का हाइट ये दिए, ओके, इससे एक परपेंडिकुलर ड्रा करो, इससे एक परपेंडिकुलर ड्रा करो इधर, इससे एक परपेंडिकुलर ड्रा करो इधर, परपेंडिकुलर, वो भी एक्स लेवल, ठीक है, वो भी आ रहे हैं. This total length would be is equal to r, already you know. This total length is r. So this point up to this point of the distance we don't know. This is a the width. What is that? This is the height of the step. The height of the step कितना बेटा वो ये है. The remaining height कितना हो जाता है बोलो? This is a remaining height is a r minus ये हो जाते हैं. Is it clear? Is it clear or not? This is a r minus a. This point of step, point of contact below, point of contact below. Okay. So you see from the center, what happening is there? This weight will acting downward direction. I say mg. Mg is acting downward direction. Okay. So from this, the force will acting along the direction. The applied force is acting along this direction. Okay. When the wheel is step up, so the torque experienced by this weight, which is approximately equal to the torque experienced by the force about this point 2. Okay. When the wheel is step up, when the wheel is step up. So what conditions are applicable here? See, when the wheel is step up, what conditions are applicable? The torque experienced by the force. Torque experienced by the force is greater than or equal to the torque experienced by the center of mass of the wheel. That is equal to tau mg is approximately equal हो जाता है for minimum force. What is the torque experienced by the force? This is a force and the perpendicular distance about this point of contact. You have to calculate about this point of contact. About this point of contact, the torque acting on the wheel due to this force is given by F bar cross R bar is greater than or equal to R bar. Capital R ले बेटा, capital R है, capital R ले. This is up. Capital R is greater than or equal to mg. Force, इसका force है about this point of contact of perpendicular distance क्या है बेटा? X है. That is mg into x. But what is the value of x? From this diagram, see, x square is equal to r square plus r minus a whole square. R minus a whole square. So from this x square is equal to, what is that? Sorry, r square is equal to x square plus r minus a whole square है. गलत हो गया देखो इधर, गलत हो गया देखो इधर थोड़ा और भी लो इधर. Okay, from this right angle triangle, it is very clear that r square is equal to x square plus r minus a whole square. Because of it is 90 degrees, no, it is hypotenuse. Therefore, r square would be equal क्या हो जाता है बोलो? R square is equal to x square plus r minus a whole square है ना, ठीक है. x square is equal कितना बेटा? R square minus r minus a whole square हो जाता है. और x is equal क्या हो जाता है बोलो? Root over r square minus r minus a whole square. This is a perpendicular distance of the center weight of the object. These two values are put in this equation. In this equation mein lagao. So what you will getting see here? F cross R greater than or equal to mg into x. X value कितना बेटा? Root over r square minus r minus a whole square. Or f is equal, what is the value of f? F is greater than or equal to mg upon r into root over r square minus r minus a whole square हो जाते हैं. और एफ मिनिमम इज क्या हो जाते हैं? पर मिनिमम फोर्स का एफ मिनिमम क्या हो जाता है बोलो? mg इंटू वो अंदर लेके जाओ आर स्क्वायर हो जाते हैं ना, आर स्क्वायर अपॉन आर स्क्वायर है माइनस आर माइनस ए अपॉन आर होल स्क्वायर के बराबर हो जाते हैं. इज इट क्लियर? आर स्क्वायर अंदर चल जाओ आर स्क्वायर हो जाते हैं ना, आर स्क्वायर है. दैट इज द मिनिमम फोर्स. द मिनिमम फोर्स इज इक्वल टू mg इंटू रूट ओवर 1 minus r minus a upon r whole square. इतने मिनिमम फोर्स एक्ट हो जाते हैं. फॉर दिस मिनिमम फोर्स द व्हील वुड बी स्टेप अप. इज इट क्लियर? इज इट क्लियर और नॉट? बहुत आसान प्रॉब्लम है और जे 2025 में पूछे. हाउ मच अमाउंट ऑफ द फोर्स विल एक्टिंग फॉर व्हाट वैल्यू ऑफ फोर्स द व्हील वुड बी स्टेप अप. कितना फोर्स एक्ट करना लगता है बेटा? एफ मिनिमम इज mg into 1 minus root over a minus r minus a whole square over r. Is it clear? No doubt. Next to angular momentum. What is an angular momentum? Angular momentum. Next concept is a angular momentum. Angular momentum. What is an angular momentum? The angular momentum generally defined as like this. Suppose consider a two-dimensional plane. Okay. A particle would be at a distance of r है बेटा. r है. इस डायरेक्शन ऑफ पार्टिकल है. इसके लिए क्या लगा दिया? एक मोमेंटम ऐसा लगा दिया p is equal to mv. Okay, making some angle of theta which is moving with the velocity of v and mass m. इस पे देखो वो भी एक्सटेंशन करो, वो क्या हो जाता है? परपेंडिकुलर डिस्टेंस हो जाता है. वो भी r है, ठीक है, वो भी थीटा. जिस r परपेंडिकुलर इज क्या है बेटा? r sin थीटा हो जाता है. r perpendicular is क्या हो गया? r sin theta about this point O. Is it clear? Therefore, the angular momentum can be defined as L about this point O. The angular momentum can be defined as L is equal to the product of perpendicular distance r perpendicular into its momentum P is equal to mv. R perpendicular distance into momentum. But r perpendicular distance is also already know. L is equal क्या हो जाता है बेटा? r sin theta क्रॉस p. और सिंपली L is equal क्या लिखना पड़ता है बोलो? rp sin theta. The angular momentum would be is equal to rp sin theta. It would be changes with respect to change of the angle. It may be two cases are there. What are the two cases? If theta is equal to 90 degrees, L is equal क्या हो जाता है बेटा? R perpendicular into P. That is equal to R perpendicular into mv. और L is equal क्या लिख रहा बोलो? R into P perpendicular. That is R into mv. Both will be give the same concept. Okay, this is a angular momentum. The product of what is that? momentum and perpendicular distance, therefore the point of reference is called as a angular momentum. Suppose consider rigid body है बेटा. Suppose consider rigid body है. एक rigid body ऐसा है. The rigid body is rotating like this. So the rigid body is rotating like this. वो भी rigid body है बेटा. ऐसा rotate कर रहा है. This is a rigid body. About this axis of rotation, which is rotating like this. This is an axis of rotation. Axis of rotation. A rigid body of mass m, which is rotating with an angular velocity omega. Okay. About this point O, we have to calculate the angular momentum here beta is getting. Let be a small elementical part dm, which is at a distance of x from this axis of rotation and moving with velocity v is equal to x into omega. So the angular momentum about this point O is given by di. dl is equal to, what is the dl? What's the dl? dl is equal to r cross r into dm into v. That is dl is equal to r value कितने बेटा? r value x है ना, x into dm into v is equal to x omega है. इंटीग्रेशन करो, इंटीग्रेशन ऑफ dl is equal to इंटीग्रेशन ऑफ क्या हो जाता है? इंटीग्रेशन ऑफ dm into x square into omega. Okay. So how many particles it will be consisting? So many number of particles are consisting. No? Let's say this is a dm1, this is a dm2, and so on. In number of particles are there. Integration of dm is equal to the total mass of this object. Is it clear? Therefore, integration of dl means L is equal to what I am writing here. Dm means m into x square into omega. M into x square. The product of its mass and perpendicular distance from the axis of rotation is given by moment of inertia. That is L is equal to कैसा लिख रहा हूँ बोलो? I into omega. So L is equal to I omega. This is also called as the angular momentum. L is equal to I omega, or L is equal to mvr, or L is equal to what is that? R cross P sin theta. These all are nothing but different forms of an angular momentum. Is it clear? बहुत आसान concept है, but it is very important for JEE mains and advanced and NEET also. Okay. Next see, L is equal to I omega. This is I am expressing in the different forms here, beta. Okay. So what is the torque? Torque tau is equal to already know. Torque tau is equal to I alpha is already you know, and L is equal to I omega, I into omega is also already you know. Or L is equal to what I am writing? L is equal to R cross P also already you know. The product of perpendicular distance and momentum is also called as angular momentum. So this is what I am writing. See here, dl upon dt. Derivative karo. Derivative on both sides with respect to time. This is what I am writing. See, r into dp upon dt plus p into dr upon dt. So where r is the constant, derivative of constant value could be 0. This value is equal to 0. Okay. So dl upon dt is equal to what is the dl? dl upon dt is equal to r into dp upon dt है बेटा. But according to the Newton's second law of motion, the rate of change of momentum of a body which is equal to external force acting on it. But according to Newton's second law is already know. What do you know? Say F is equal to dp upon dt. This value substitute in the above equation. Therefore, dl upon angular momentum is a vector quantity. dl upon dt is equal to क्या हो जाता है बोलो? R cross F. R cross F है ना? But what is the value of R cross F? R cross F is nothing but what is beta? R cross F. This is also we can write in the different forms. Or this is also R cross F है बेटा. The product of perpendicular distance and force is called as a torque tau here. That is torque tau is called I alpha is equal to R cross F. But dl by dt is equal to R cross F. So from these two equations, it is very clear that let's say this is equation number 1 and this is equation number 2. From these equations 1 and 2, it is very clear that what is that dl by dt is equal to dl by dt is equal to what is that R cross F. R cross F is equal to torque external. This is called as the torque tau. Now tau is called as the external torque here. That is torque external. This is a relation between angular momentum and torque. Suppose if the external torque acting on an object would be 0, then what happening about the angular momentum matter? If torque external will be 0, then what happening is that dl upon dt is equal to 0. dl upon dt means 0 means what's the value of L? L value must be constant because of derivative of constant value 0. No? Therefore, dl upon dt is equal to 0 means what is that? L must be is equal to constant. When L must be equal to constant means L initial would be is equal to L final same hona padte. But what is the L initial is equal to L final? That is I1 omega 1 is equal to I2 omega 2. This is called as a law of conservation of angular momentum. This is called, what is this called? This is called as law of conservation. Law of conservation of angular momentum. Law of conservation of angular momentum. Angular momentum. Law of conservation of angular momentum. What is the law of conservation of angular momentum? Li is equal to Lf. That means Li minus Lf would be is equal to 0. If the net moment on a system would be equal to 0, then that momentum is called as the law of conservation of momentum. In the case of law of conservation of momentum, what happening is that initial angular momentum of the system would be is equal to final angular momentum of the system. Next, dl by dt is equal to क्या है बेटा? dl upon dt is equal to, is it clear? What is the dl? dl is equal to tau into dt. Tau into dt. Integration करो, integration of di is equal to integration of tau into dt. From dl है बेटा, this is dl li to lf t1 to t2. This is lf minus li. I am writing in the form of integration of t1 to t2 tau into dt. This is called as the angular impulse. A large force acting with a short interval of time is called an impulse. In Newton's laws of motion, impulse mein ho, when an object is moving in the straight line, the product of force into momentum is the product of force into time is called as an impulse. Whereas in case of rotational mechanics, the product of torque and time, a large amount of the torque is acting in a very short intervals of time is called as the angular impulse. The angular impulse would be equal to what is this is the angular impulse. This is an angular impulse. This is what I am writing. See delta L. Delta L is equal to what is that? T1 to T2 into tau into dt. Is it clear? Is it clear or not? Both important here. The law of conservation of angular is a very, very important for J mains and advanced and NEET also. Okay. It's based on the concept to see the problems. Next problem देखो बेटा, JEE 2025 में पूछा है और बहुत आसान प्रॉब्लम है, based on the concept of law of conservation of angular momentum. Suppose consider a particle. Suppose consider a particle है बेटा. So particle. A particle is projected with an initial velocity v naught. With what velocity it was projected? The particle is projected with initial velocity v naught, making an angle of 45 degrees with the horizontal. Okay. Then the particle has to be when to reach that maximum height. And its maximum height. This h max, maximum height. Then find the angular momentum of the particle about this point of projection. Point of projection से angular momentum निकालना पड़ता है. कैसा निकालना पड़ता है बोलो? The particle of mass was also given m beta is the mass here, which is projected in the x-y plane. So this is x level, this is a y level. Find the angular momentum of the particle at the maximum height. Find the angular momentum. Find the angular momentum of the particle at h max. And the particle has to be reached at h max. Find its angular momentum. Angular momentum निकालना पड़ता है. बोलो. Here initial velocity will be the two-dimensional plane here. It will be resolved to rectangular components. Along the x-axis, vx is क्या हो जाता है बोलो? V naught cos 45. That is equal to V naught upon root 2. Along the vertical direction, Vy is क्या हो जाता है बोलो? Vy is equal to V sin 45 है. That is V naught upon root 2. About this point, we have to calculate the angular momentum. About this point, what is the perpendicular distance? The perpendicular distance of the particle would be is nothing but h max. That is we should have to calculate now. Okay. What is h max? H max is equal to u square sin square theta by 2g is already known. That is h max. U square means v naught square sin square 45 upon 2g. Therefore, h max is the v naught square into sin square 45 value 1 by root. 1 by root 2 of 4 square is a 1 by 2. 1 by 2 into 2 is there. V naught square 1 by root 2 of 4 square, no. 1 by root of 4 square by 2z. That is h max is equal to v naught square upon 4 g. This much maximum height, it can be inches. Now we have to calculate the angular momentum. What is the angular momentum? L is equal to m into Vx into h max beta. H max pk. M into Vx means v naught by root 2. V naught by root 2. What is the value of h max? V naught square by 4g. That is the angular momentum would be is equal to m v naught cube upon 4 root 2 into g. This is the angular momentum of the particle about this point of projection. Is it clear? Is it clear or not? Okay. No doubt. Okay. Huh? Any doubt? Do you have any doubt in the concept of law of conservation of angular momentum and torque, and what is that angular impulse? Ask on the scrolling number.
ఎవరికైనా డౌట్లు ఉంటే అన్మ్యూట్ ఆప్షన్ ఇచ్చేసాము, అన్మ్యూట్ చేసుకొని క్వశ్చన్ అడగచ్చు. నర్సాపూర్ వాళ్ళు హ్యాండ్ రైజ్ చేశారు, మన డౌట్స్ ఉంటే అడగచ్చు. శ్రద్ధగా సిఓఈ గర్ల్స్ కానీ, కొండమల్లపల్లి కానీ, భద్రాచలం కానీ చాలా శ్రద్ధగా వింటున్నారు క్లాస్. వాళ్ళకు కూడా ఏమైనా డౌట్ ఉంటే దయచేసి అడగచ్చు. మిగతా వాళ్ళు కూడా వింటున్నారు, కనపడిన వాళ్ళ వీడియోస్ ఆన్ చేస్తున్న వాళ్ళు. ఇప్పుడే టర్న్ ఆన్ చేసిన వీడియోస్ ఆన్ చేసిన వాళ్ళకు కూడా ఏమైనా డౌట్స్ ఉన్నాయండి? ఎనీ డౌట్స్ దయచేసి మీరు సార్ అడిగినట్లయితే మీ డౌట్స్ అని క్లారిఫై చేయండి.